Welcome back to multiplying fractions. Now we're going to be looking at a different way to multiply fractions using the area model, the way that we've been building up to this for a very long time, from the very beginning of when we were defining unit fractions. So first, we need to remind ourselves about the two things that we're going to be looking at. So when we look at fractions, for example, the unit fraction, first of all, and especially as a dimension on number line, remember that the first thing that's really important to pay attention to or to be able to identify is the whole. And the whole for the unit fraction is the distance from 0 to 1 on a number line. So for the dimensions, right, a fraction, when we're measuring distance or dimension, is going to be is going to have a whole that is 0 to 1. So then whatever the fraction is, let's say this piece, this distance is going to be a half, because you need two of them to make the whole, right? So whatever this base distance is, that's going to be what we're going to be measuring our unit fractions up against. Now, so that's the first thing. So whenever we have dimensions or distance or length, right, the whole is the distance from 0 to 1 on a number line. Okay. The second thing we need to look at is the area. So the area model for multiplication is where we talk about A times B as the area of a rectangle of two dimensions, A and B. Okay. So generally, if we're measuring our dimensions in some sort of unit, the whole for the area is going to be some kind of a rectangle or a square, but that is 1 by 1. Okay, one length unit by one length unit. And generally when we're measuring in centimeters or measuring in inches, the 1 inch is the same as the other inch. So often when we're actually physically measuring, our area is the 1 by 1 square. But if the vertical was measured in inches and the horizontal was measured in feet, then we wouldn't have, it would be a rectangle, but it would still be a 1 by 1 rectangle. So the area is then the unit, the whole for the area is going to be a rectangle, a 1 by 1 rectangle. So the whole for the unit fractions, when we're talking about lengths, is a distance from 0 to 1, and the whole for the area model is going to be a rectangle, a 1 by 1 rectangle. So what we're going to do today is we're going to combine these two into the area model for multiplying fractions. So let's take a look at how we're going to view it. So we have two fractions that we're multiplying. So these two are lengths or dimensions. And we have a product, which is going to be the area. So we know that the whole for the length or dimensions is going to be the distance from 0 to 1, and the whole for the area is going to be a 1 by 1 rectangle or square, depending on whether the units are the same or not. So now, in order to make sense of this picture, I'd like to take you to the app where this was made. This was made in GeoGebra, and we're just going to go and play with that app a little bit and make sense of what's going on there. So we can have the numerator, which is, the first fraction right here, which is on the y-axis, and the second fraction, which is on the x-axis. And we can play with the values of the function. So let's say it's 8/7, right? And it's 10/7, or for example, it could be 10/13, right? Or here on the denominator, again, we can have 12, 9, 7/8, or we can play with the denominator 7/12. Now, what doesn't change? If we look at it a little bit further, let me look at, make it 10/10 on the y-axis. What do you think this line, the green line, is representing? Do you see that when we have 10/10, our green dot is exactly on that green line, but if we move that dot off, right, the green line remains in the same place. Okay, so that green line on the y-axis is actually 1. Let's see if that's the same thing for the x-axis. What if I change the numerator to 12? Oh, there we go. That again falls on the green line. So the green lines represent the 1. So the green lines will show 1, and then the next green line will be 2, and then the next green line will be 3. And what happens, so then the distance between each green line is the hole that we had been talking about, the distance between 0 and 1. Now in this case, on the vertical line, we see that we have, and I can't draw on this thing, I can't annotate this thing, but in GeoGebra, but you can see that if I make it a little bit smaller, let's say we have 4/4. Oops. Sometimes it's hard to, there we go. So you see that the vertical hole is split into 4/4 because you need 4 of them to fill the hole, right? So it makes sense that then 4/4 would lie on the green line. Now the horizontal hole, the 0 to 1, is actually a different distance. And it doesn't really matter because sometimes, as we talked about, the distance is can be measured in different units. So it could be in feet or centimeters or inches or whatever you'd like, miles, whatever you'd like. So a 1 by 1, a 1 on the vertical and a 1 on the horizontal don't actually have to be the same distance. So, but you see that the horizontal hole is split into 12s because you need 12 of them to make the 1. So right now what we have is a shaded 1 by 1 rectangle. Right? So that is our 1 by 1 rectangle. Now, what if I change my denominator? Excuse me. My denominators or numerators, so that the shaded, so that I'm not shading the whole. Now I'm shading part of the whole. And I have my little squares for the area that what I'm now talking about are smaller. They're 1/7 of the vertical distance and 1/12 of the horizontal distance. And in my actual shaded area, I have 4 by 6, right? So I have 4, yeah, right, 4 by 6. So that would be 24 of them, right? But how many of them do I need to fill the hole? And the hole is our rectangle, the 1 by 1 rectangle. So that would be my 7 by 12 array, right? So I could figure out what that is, and that's 84. All right, so this is going to be 24/84. Okay, so you see how you can play with this and this particular app and figure out how to model the fractions. Now, how to then interpret the fractions is our next task. So I'm going to go back to drawing this out. Now that you see what this looks like, I'm going to go back to drawing this out and interpreting it in a little bit more detail. So let's take a look at our example. So our length, the 1, the whole for the vertical is this 0, distance 0 to 1, and the hole for the horizontal is that. So let's now look at what's being represented on our dimensions, on our lengths. So we have two lengths, those are the factors, and we have an area, which has a different hole. So the two lengths, well, we have that this is 1/3 because we need 3 of them to fill the hole. So that mark represents 1/3. So this distance would be 2/3. So 2/3 is our vertical factor. And this distance is also 1/3 because you need 3 of them to fill that length hole. So that is our 1/3. So what we're doing is we're multiplying 2/3 by 1/3. Our two dimensions of the rectangle that we're interested in are 2/3 and 1/3. So that's our multiplication that's represented here. Now let's figure out what the actual answer is, what the product is. And if we look at the product, then we're going to see that the 1 by 1 rectangle, in this case it's actually a square, is this. Right? Now, the area that we're looking at is this shaded area. It's made up of 2 little rectangles, and so there are 2 rectangles that we have. But how many of those rectangles do we need to fill the hole? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one of those is a ninth. So it's actually 2/9. So notice that so again, on the left, with our factors, we're looking at what we labeled as the yellow. So the hole is the yellow length. For our product, the hole is now the area. So we're multiplying 2 lengths to get an area. Let's see what we can do with the hole, with the next problem. Let's go. Okay, so we're multiplying 2 lengths, 2 dimensions, and each one of those dimensions is going to be represented as a fraction. So this is 1/3 because you need 3 of them to fill the hole. And this is 1/5. We need 5 of them to fill the horizontal hole, but we have 3 of them in our dimension. These are the dimensions we're looking at. Okay. All right, so this is our vertical length. This is our horizontal length. And the holes that we've labeled them with are in yellow. Now, let's look at the area, the answer now. The hole for the answer is that 1 by 1 rectangle. Okay, that's our hole. It's going to be our 1 by 1 rectangle. The area that is actually the area of the rectangle with those dimensions is this, and it contains 3 pieces. Each one of those is, what fraction is that? How many of them do we need to fill the hole? Well, if we count how many of these little rectangles we need to fill the hole, we got 1, 2, 3, 4, 5, 10, 15. So each of them is 1/15. So we have 3/15 as our product. So 1/3 times 3/5 is 3/15. Now, the answer should not be a surprise for you because, in the procedure that we learned, the algorithms that we learned, we say, quote, multiply the top and multiply the bottom, but we really don't, most people do not understand why we do that. They just follow the rule. Now, this is attaching a picture, a drawing, a diagram to that process so that now each of those numbers can be interpreted in that picture or diagram. Let's try number 3, and then we'll make some generalizations. So let's look at, again, we have 2 factors that are being multiplied. Okay, these are our holes. So this factor, each one of these distances is going to be 1/5. So this is 4/5. 4/5. And each one of these horizontal distances is a 1/6. No, a seventh. A seventh. 1, 2, 3, 4, 5, 6, 7. Seventh. And we have 6 of them. 6 sevenths. All right, so this is what we have for our factors. We have figured out what the problem is that we're trying to solve. Now let's look at the product. The whole for the product is this 1 by 1 rectangle. And the area that we're looking for is the shaded rectangle, because those are our dimensions, right? So the shaded rectangle is made up of these little rectangles. And let's see if we can figure out, well, first, how many there are. So how many in area. And also we need to figure out how many to fill the hole. All right, so how many do we need to fill the hole? There's 1, 2, 3, 4, 5 rows of 7 columns. So 5 rows of 7 to fill the hole. That's 35. And how many in our area? Well, 1, 2, 3, 4 by 6. So 4 rows of 6, and that's 24. Okay, so interesting. Why is it, I'm going to switch to a completely different color here. Why is it that when we have 24 was the number of rectangles that fit into our area here, and that was 4 by 6, right? That's how we got that 24 was 4 by 6. Well, this is our 4 and 6. Why does it make sense that the area, the number of rectangles that we need to fill the shaded area is 4 by 6? Well, look at how the 4 comes about. Well, the 4 is the number of these fifths that we have, right? So there's 4 rows of them. And the 6 is the number of the sevenths that we have in here on our actual dimension. So there's going to be 6 columns. So these numbers, the 4 and the 6, actually represent how many of each of what the dimensions are of the shaded region. Right? Now, when we look at the 35, it was 5 by 7. Well, the 5 by 7 represent how the hole distances are cut up. How the hole distances are cut up, right? So how big these little rectangles are and how many of them fit into the dimensions. So if each one of these is a fifth, then the whole distance here, the 0 to 1 on the vertical, will have 5 rows. If each one of this is a seventh of the horizontal, if which one of these is a seventh of the horizontal, then the whole is going to be cut up into 7 columns. So this multiplication actually are the dimensions of the shaded region, and on top of that, the dimensions, let's say, I'll mark it here, the dimensions of the whole, right? So how many pieces we have shaded, that's going to come from our numerators, and how many pieces we need to fill the hole is going to come from our denominators. So let's take a look at drawing these and see if we can interpret them. So we need 1/3 times 1/6. And remember, so the x and the y, so the vertical and the horizontal holes don't actually need to be the same. They just need to make it a little bit easier for us to see the picture. So if it's 1/3 and 1/6, if I'm going to use the grid, I can say, all right, well, this is going to be my 1. All right, that's my 1 line. And this is going to be my 1. That's going to be my 1 line. So 1/3 is going to be here, and 1/6 is going to be here. So the shaded area is going to be this. It's just going to be one piece. But how many of those pieces will fill in, will we need to fill the hole? Remember, the hole for the area is a 1 by 1 rectangle. How many of those do we need to fill the hole? We have 3 rows and 6 columns. We have 18. So number of pieces we have, and number of pieces we need to fill the 1 by 1 rectangle. Okay, let's try to do the number 5 here. 2/3 times 2/5. All right, so the vertical is going to be cut into thirds. So this is a third. So we can use this. I was doing that in green. So this is going to be our 1. And the horizontal is, we're going to be looking at fifths. So 5 of those would make up a whole. So this is going to be our 1. So let's label 2/3 by 2/5. This is the area we're looking at. Okay, all right. So let's take a look. How many pieces, these little rectangles, these little squares, are going to be in that area? Well, we have 4, right? Because we have 2/3 on the horizontal, on the vertical, and 2/5 on the horizontal. So we'll have 4 pieces altogether. And how many of these pieces do we need to fill the hole? Well, we have 3 rows by 5 columns. So that would be 15. And the whole 1 by 1 rectangle is this. Okay. And do you see again that this is the number of pieces in our area? That's 4. And this is the number of those pieces that we need to fill the hole. All right. I'm going to leave 1/4 times 2/7 for you to figure out. Oh, and also, you don't actually need to be using the graph paper. Some people find it actually more restrictive, and it's easier for them to just draw it by hand, because they would say, okay, that's 1/3. So this is 2/3. So this is going to be my 1. And if this is my horizontal 1, then that would be 5ths. Right, so this would be 2/5. So some people don't actually use the grid, but it's completely up to you. It's up to you whether you use it or not. Okay. All right, so I'll leave 6 for you to work through, and let me know if you need me to go through it on a different video. And let's do the same with 7. Number 8, let's take a look here. So I'm going to use let me use the grid. So 1/3 times 3/4. So 1/3, if that's a third, then this has to be 1. And by 3/4, if this is 3/4, then 1 would have to be here. Okay, so the area we're going to be looking at is going to have 3 pieces. And each one of those pieces, how many do we need to fill the hole? Well, it's 3 rows of 4, so we'll need 12 of them to fill the hole. Okay, remember the hole for the area is this. Okay, so 3/12. Now, many of you will say, yeah, but 3/12 is actually a quarter. Would we be able to, right, as a quarter? Well, would we be able to figure out why that's a quarter here? Well, let's see. I'm going to pick a light blue. Why is this 1/4? Can we find how we could use 3 of these to fill the hole? Well, do you see that this is the second one? And this is the third one. And there's the fourth one. So it is in fact 1/4. Or 3/12. So we can certainly simplify that. I will leave number 9 for you to work on. Now, let's look at part 3 and see what happens when all of a sudden we have dimensions that are greater than 1. Now, based on what we already know, this is going to be our 1 by 1 hole, and these are our dimension holes. So we've got a different situation here. If this is 1 and 1, then what are the dimensions of our shaded rectangle? That's very interesting. So what is this distance? Well, how many of them do you need to fill your dimension hole? You need 3. So this is 1/3. So over here on the green line, which is the dimension of our shaded rectangle, we need 4 of those thirds. 4/3. Or we could also write it as 1 1/3, right? Okay, let's do the same thing on the horizontal. Each one of these is 1/5 because we need 5 of them to fill the hole. But we actually have the hole and 6/5, 7/5, 8/5. We actually have 8/5, or 1 3/5. Okay, so let's see if we can figure out the area of the shaded region. The shaded region is this, and it's made up of a bunch of these little units. Now, how many of the little units do we have in our area? Well, in our shaded area, we have 4 rows of 8 columns, don't we? 4 rows of 8 columns, so 32. And how many of them do we need to fill the hole? Well, we have 3 rows of 5 columns, 15. So that's certainly an answer, a form of an answer. All right, so we have 32 of them in the shaded region and 15 of them to fill the hole. And yeah, it happens to be an improper fraction. We can see on the picture that it's greater than the hole. But I wonder if there's another way that we can count, we can write this. So we know that this region is 15, right? 15 of them. Now, let's see if we can make another hole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that region is another hole, another 15, right? So there are 2 holes and 2 more 15ths. So we could also make sense of the same problem in terms of whole numbers or mixed numbers. Okay. Let's try one more and then I'll leave the last one to you. So 12. Again, let's identify the holes. So this is our area hole. And these are our dimensional holes. So each of our dimensions is cut into, or the vertical is cut into fifths. And we have 9/5 on the horizontal. So this is 9/5. Now, the horizontal is also cut into fifths. And we have 6/5. 6/5. Okay. So how many of these little units, these little rectangles, do we have in the shaded region? Well, we have 9 rows by 6 columns. 36. I'm sorry, 9 rows by 6 columns. How about 54? 9 rows by 6 columns. And then how many of these, what part of the whole are they? Well, they're 5 by 5, so they're 25ths. So we have 54 25ths. That's our answer for the area, 54/25. Let's see if we can make sense of this using mixed numbers. So 9/5 is 1 and 4/5. All right, we can see that. That's 1 and 4 more fifths. And 6/5 is 1 and 1 more fifth. And this is 25 of them. Well, let's see if we can find another 25. So this is 4 by 6. There's 24. And one more will give us the other 25. So that's another 25. So that's 2 wholes and 4 more left. All right, so that makes sense as well. Okay. Now, and the last example here, or last type of example here for our for this video is going to be what happens when we now introduce wholes. Okay, so we can certainly do that. Let's see, 3 times a sixth. So on the vertical, we're actually counting by wholes. This, oops. This is our, oops, my goodness, that's really thick. This is our whole. And we have 3 of them. And we need to multiply that by a sixth. So if this is our sixth, then the whole would be here. So that. And the area that we are going to be shading is 3 by 6, pardon me. 3 by 6. This is the area. Okay. All right. Now, what's our area whole? You remember it's a 1 by 1, and it could be a rectangle. 1 by 1. This is our area. Interesting. So let's see how we can interpret that. So, in our shaded area, we have 3 pieces, right? Because it was 3 rows of 1 column. In our whole, we have how many pieces? 6. So we need 6 of them to fill the whole. So that's 3/6. That's interesting, because we know that could be simplified to a half. Oh, let's see if we can simplify this. We'll make sure that this blue is a half of the purple. Well, one of these blues, how many of those do you need to fill the purple hole? Do you see that there's 1? And then there's 2. So it is 1/2. So this is 1/2. That's 1. Okay, let's try one more example, 14. So we have 5/7. So if this is a 7th, then we have 2, 3, 4, 5 of them. That's going to be our dimension. And our 1, we need 7 of them to fill the 1. So that's our 1. And on the horizontal, we have 2, and our 1 is this. So where's our area? So 5/7 times 2. This is the area that we're looking at. And what is the whole for our area? Well, it's a 1 by 1 rectangle. So that's a 1 by 1, wherever that is. 1 by 1. So let's see if we can follow through with what we've already done before. We are using these little rectangles as the units. How many of them do we need for our area? Our area is the blue shaded region, so we need 5 by 2. So we need 10 of them. And how many of them will fill the hole? 7. So it's 10/7. Okay. Now my question to you is, how do we know, how can we show that it's also the same as 1 and 3/7? So I'm going to leave that for you to figure out. How do we show that 10/7 here is the same as 1 3/7. And then you can also look at number 15 with 3 times 5. Okay. Now, what if we have mixed numbers? We've actually looked at mixed numbers on that app already. So let's say that we'll do 16 and then I will leave 17 and 18 for you. So let's see, we got 1 2/3 and 1 by 1 1/5. So if this is a third, 3 of those will make a 1, and 1 2/3 is here. So this is going to be our area. We don't know how wide it is going to be yet. And 1 1/5. So this is 1/5. We'll need 5 of them to get to the 1. And this is 1 1/5. So there we go. Our area is going to be 1 2/3 by 1 1/5. All right, that's the area. These are going to be our little units that we're going to be counting. Well, how many of these units are in the area? Well, we seem to have 5 rows of 6 columns, right? 5 rows of 6 columns. So 30. That came from 5 times 6. And let's go focus on our holes now, because we need to know what size those pieces are. This is our area hole, and these were our dimensional holes. So how many of those fill the hole? We have 3 rows of 5 columns. So 15, 3 rows of 5 columns. Okay. Now we know that 30/15 is 2, so let's see if we can go find that. So there's our 15. So that fills the 1 hole. And then we have 2 by 6. Right, so there's 12. And then 13, 14, 15. 15. So this is another 15. So there we go, that's 2. Okay. So what I would like you to do is work on number 17 and 18 and let me know if you have any questions that we can then that I can answer in a different video. And we will leave it at that. So what I would like you to do when you're done with this is explain why we multiply the numerators and denominators. Why do we do that? Why does it make sense to do that? Right? And what we need to do is use a drawing for this. Okay. I will see you in the next video.